Alright, so welcome to the third video in the forces topic. In this video we'll have a little bit of a break from Newton's laws and we'll look at some of the special forces that you will be dealing with very often in solving force problems. So they should be called standard forces rather than special forces, but the pun was obviously far too good to resist. So we'll be looking in this video at the weight force and the normal force. So weight is a term that we use every day, but in an everyday context we use it incorrectly. So hopefully by the end of this video you'll be able to tell me why. So weight is the gravitational force on an object. And we know by Newton's second law that the force due to gravity is equal to the mass of the object times the acceleration due to gravity. And that gives us our equation for weight. So since the weight is a force, the units of weight are also newtons. So unlike mass, which is a constant value, weight depends on the acceleration due to gravity. So if we have a man and he weighs 60 kilos, his mass will always be 60 kilos, but his weight will depend on the acceleration due to gravity. So on Earth, where the acceleration due to gravity is 9.81 meters per second squared, his weight will be equal to 60 times 9.81, which is roughly 590 newtons. But on Mars, his mass is still the same, his mass is still constant at 60 kilos, but the acceleration due to gravity is 3.77 meters per second squared. So his weight will be equal to 60 times 3.77, which is approximately 260 newtons. So the second force is the normal force, and this is a force we will encounter quite often. So when you stand on Earth, Earth's gravity pulls you down, it pulls you towards the centre of Earth, but you don't sink through the floor, you stay where you are. So that indicates that there must be another force acting on you that keeps you stationary. So the effect is much easier to see if you're standing on something slightly softer than the Earth, so for example a mattress or a piece of foam or a soft cushion. When you stand on it, it will deform. It will sink under your weight, but you won't go through it. At some point it'll stop sinking. So when you stand on the mattress, as when you stand on Earth, you're exerting a force on it. This is your weight or the force due to gravity. And that force causes the mattress to squash or to compress a little. And the mattress doesn't want to be compressed. It wants to be in its equilibrium state, very much like a spring. So like a spring, when you push down on the mattress, it will push back on you. And the force that it pushes back with, we say, is the normal force. This is the force normal to the surface that you're standing on. And exactly the same thing happens when you stand on Earth. So you push down with your weight force, and the Earth pushes back with a normal force. The only difference is the Earth doesn't deform visibly when you stand on it, which is probably a good thing. The important thing to remember about the normal force is that it is always exerted perpendicular to the surface. So there is often some confusion, and there's often thought that the normal force is the opposing force to the gravitational force, and this is not the case. So the normal force is always perpendicular to the surface that the object is pressing on.